Hello student, we'll see PWM signal generator. See, PWM is widely used in industrial control. We know in DC motor interfacing, we have seen that to run the motor with some duty cycle means it's given in percentage, like 50% duty cycle, 20% duty cycle, 75% duty cycle. So like that, the duty cycle means what? It is the signal is high for that much time. So the PWM generally generated using CCP module is capture compare PWM generation module. So there are some steps we have to consider and some formulas are there. In PWM, two factors are important. What are that factors? The period of the pulse and its a duty cycle. When I say 20% duty cycle from 5 milliseconds, that means it should be on for 1 milliseconds because the 25% of that 4 milliseconds and 3 milliseconds will be off. They use CCP module and timer 2 and PR2 resistor. So we'll see the calculation. Here is a time. PWM time is equal to PR2 plus 1 into 4 into N into T oscillator. What is meant by it? PR2 is a resistor which hold the count for the PWM pulse, whereas a TPWM means the time of that PWM pulses. This N is nothing but prescaler. The prescaler we already seen in timer, and the 4 is why? Because we are using internal clock frequency, that's why it's divided by 4. The T oscillator means your crystal frequency. So T oscillator is nothing but here 1 by S F oscillator, that is crystal frequency. So N is a value of prescaler, 4 is automatically we can using the machine's internal machine cycle clock frequency. So machine cycle divided by 4 and PR2, and the PWM means the actual time of that frequency. So PR2 is equal to F oscillator divided by F PWM into 4 into N minus 1. I say it is used with timer and CCP module for PWM generation. So for that we are using timer 2 control register. So timer 2 is not in our syllabus, but we have to, right now I'll explain you what is mean by it and what are the bits in T2 con. T2 con is a timer 2 control register. The first two, T out PS3 and T out PS2 and T out PS1 decide post scale value. We are having two, prescaler and post scaler. So these three will decide the post scale. If it is 0 0, then it is 1:1 post scale. If it is 0 0 1, then it is 1:2. If it is 0 0 1 0, then it will decide this 4 will decide the post scale. 0 0 1 0, all 0 will decide the 1:1 post scale. 0 0 0 1, it is 1:2 post scale. 0 0 1 0, it gives the 1:3. So we are having 16 combination with these 4 bits. Then TMR2 on, it is TMR timer 2 on, and off. It is 1 means enable the timer 2 and start the timer, and 0 means it is stop the timer 2. Then these two will decide the prescaler value. If it is 0 0, then its prescale is 1. If it is 0 1, then prescale is 4, and if it is 1 1, it's decide the 16. This will goes over here. If the value is more than 255, the value is the PR2 value is more than 255, because see, PR2 is 8 bit. PR2 is how many bit register? It is only 8 bit. So 2 raised to 8 will gives only combination up to 255. That means if your PR2 value is goes beyond, it is greater than 255, we have to use prescaler, either divide by 4 or divide by 16. We are having how many combination? 1:1. We are having 1:1, 1:4 and 16. How many combination? We are having 1, 6, 4 and 16 combination. If it is more than 255, divide by 4. If it is in the range, then take the value of 4. So T2 con, timer 2 con register is there. Then we are having this DC1B2 and DC1B1 decimal points. This is for CCP1 con. To set this count, 10 bit counts, there are 10 bit register. 10 bit count is of 10 bit, but we don't have a 10 bit register, so the 8 bit is from CCPR1L and 2 bit from CCP1 con. Once again, to set the duty cycle, CCP module use the 10 bit register. 10 bit register is from DC1B9 to DC1B0. So the 8 bit is from CCPR1L and 2 bit from CCP1 con. So this 2 bit is from CCP1 con. See, duty cycle I say 25%. So this is your total time. From total time only 25% is on. Here total time is this. So only 50% is on and 50% is off. This is total time, 75% is on. This is 75% is on, and 100% DC is totally on. What are the steps are involved in PWM generation? Set the PWM period by writing PR2 registers. We have to calculate the first count. Then set the PWM duty cycle by writing CCPR1L for higher 8 bit. Set the CCP pin as output, because the CCP pin we have to use to generate. There are 2 pins are assigned for the CCP. Then using T2 con register, set the prescale value. Then clear the timer 2 register, because we have to load the value into it. Then configure the CCP1 con register for the PWM, whether it is 50%, whether it is 75%. Then start the timer 2. Here I have taken one program. Create 2.5 kHz PWM frequency with 75% duty cycle. From 2.5 kHz, 75% will be on and 25% will be off on the CCP1 pin. So first of all, CCP1 con will make a 0. Then PR2, I have taken as a crystal frequency 10 MHz with prescaler 4 and no post scaler. Then I calculated 186 because the PR2 into, see here I want to show you PR2. What is the formula? PR2 is equal to F oscillator divided by FPWM into 4 into N minus 1. I got the value is more than 255. That's why I taken this prescaler with 4. So I got the value is 249. Then this is 186 is 75% of this 249. Then make as a CCP pin as a input. Then T2 con. Now turn on the timer to CCP1 con. What I in earlier slide what I say, it is of 75%. So make it this 1. This is 1. Then C. In earlier lecture CCP module I explained this CCP1 con. See, this will decide the capture compare mode, compare mode. So this 1 actually, if this is 0 is 0 is don't care condition. So the binary number is 1100 and this is 11 for, this is 11 for 75%. So we are having 3C, 0 cross 3C. Once again, these 4 will decide it is capture mode, it is compare mode, or it is PWM mode. So PWM, for PWM generation we use 11. In datasheet they are given 11 don't care, 2 don't care condition. So I taken as a 1100. So it is C. Then turn on the timer, clear the timer to TMR2. Then turn on the timer 2, and this is from the, what I say in interrupt lecture I explained that this timer 2 is used as a external interrupt, peripheral interrupt. So this is peripheral interrupt bit, we have to check whether it is overflow or not. So it will give the continuous toggle with a 75% duty cycle. Thank you, student.